Dear students, in the last session we stopped with finding out the value of S2 dash. So after finding out the value of S2 dash, we can find the value of S2. Okay, so what is the S2 means entropy of the refrigerant 22 at point 2. So what is, again we can refer back to our pressure enthalpy diagram. So what is the condition of refrigerant at point 2? It will be at a superheated state. But even though it is a superheated state, but what is the peculiarity of this 1 to 2 process or the compression process? It is a isentropic or constant entropy process. So entropy at point 2 will be same as entropy at 1. Okay, but what is the condition at 1? The refrigerant will be at saturated vapor state at 1. So S2 will be equal to entropy of the refrigerant at 1, which means entropy at saturated vapor state, or SG value, corresponding to which temperature? The temperature at 1 and 4 are same, that is minus 10 degrees Celsius. So S2 will be equal to SG value at minus 10 degrees Celsius. So that is given over here. S2 will be equal to SG value at minus 10 degrees Celsius. Okay, so what is the SG value at minus 10 degrees Celsius? We can refer back to our data book. SG value, so the SG value, for vapor state, the entropy value, SG value at minus 10 degrees Celsius. Okay, corresponding to minus 10 degrees Celsius, this blue colored region is the SG value, 1.7653, and we can note that down, 1.7653 here. S2 will be equal to 1.763. So by substituting S2 dash, S2 and T2 dash we know, then CP value we already found out. So by solving this relation, we can easily find out the value of T2. Okay, so what is the value of T2 dash? T2 dash was 35 degrees Celsius. We can convert that into Kelvin. It will be 308 Kelvin. And by solving this relation, then we can find out the value of T2 as 328.41 Kelvin. So now that we have found out T2 value, we can easily substitute that value in our enthalpy relation. Okay, and here the only unknown term was only T2. Now we have found out T2, we can substitute it here, then we can solve this relation for finding out H2 value. So by substituting this T2 value here, H2 minus H2 dash is equal to Cp times T2 minus T2 dash. So by substituting the known values, we can easily calculate the unknown value, which is nothing but H2 value, and H2 value we can calculate it as 434.57 kilojoules per kilogram. Okay. Now that we have found out H2, what is the remaining process? Why did we find out H2? Because in order to find out the work done by the compressor. Work done by compressor is nothing but m dot into H2 minus H1. H1 value we have already found out in the first part of this problem. H2 value now itself we have found out. So simply by substituting H2 value and H1 value and m dot we have already found out like this 0.316 kilogram per second. By substituting all these values, we can easily calculate the work done by the compressor or power requirement of the compressor as 10.586 kilowatt. Okay, so if you are having doubt with this unit, you can write the various units of this H values and m dot values also. Then you can easily find out the final value will be in kilowatt. Okay, so again let us move on with our question. So now we have completed the third part. Now we can find out the fourth part, which is nothing but COP. COP is we have already found out how we can write the relation for COP. COP is nothing but refrigeration effect divided by work done by the compressor. Refrigeration effect is directly given in the question, that is 50 and we have already found out the work done by the compressor as 10.586 kilowatt. Okay, by substituting that value we can easily find out the COP value as 4.86. okay, so again let us move on with our question. The last part, it is power per kilowatt of refrigeration, and we have when we discussed the performance of our VCRS, we discussed that power per kilowatt means what is the electrical power required for producing 1 kilowatt of refrigeration. So that is nothing but 1 by COP. Okay, so power per kilowatt, that is the final part of our question. It will be nothing but 1 by COP, which will be equal to 1 by 4.86, and that value is coming as 0.20546. okay, so now we have completely solved the all parts of the question, and all of you please practice this by writing down this question, and all of you should practice taking the values from data book. All of you should be thorough with or all of you should be familiar with your data book. It is very much essential when you are solving the university question papers. Okay, so thank you. So let us continue later.